Fatihah binti Saifulizam, I will explain to you guys about determinant. Determinant is a scalar value that can be used to find the inverse of a metric. The inverse of the metric will be used to solve a system of a linear equation. The determinant of a metric A is a scalar value and denoted by modulus A or that in the bracket A. Let's continue with the example on how to calculate the determinant of B. This is the metric of B. We decide to choose second column since the second column has two zero elements and easier to calculate. Since we choose second column to calculate the determinant of B, the formula will be defined like this. This is how to implement the formula above in order to calculate the determinant of B. Now, this is how to solve the number in the modulus sign.
Hi, my name is Nubatrisha Aina binti Azhari and I'll be explaining the subtopic 7.2.2 minor. So what is a minor? Minor is the value of a determinant of a matrix after deleting a certain row and column. Minor has multiple functions, that is to calculate the cofactor of a matrix, finding the determinant of a matrix, and it is also used in a joint method when finding an inverse matrix. So how do we find the minor of a matrix? Here I have matrix A. I replaced all the numbers in matrix A with alphabet A. These two small numbers beside alphabet A indicates its location. For example, A31 located in the third row and in the first column. Now we have to determine the minor M32 for matrix A. First, you identify the row and the column. The first number will always stand for row and the second number will always stand for column. So M32 indicates that it's the third row and second column. Next, draw a line across the third row and the second column. As you can see here, you are left with four numbers. Then proceed with finding the minor by doing cross multiplication with the four remaining numbers. Then you subtract the value. Your final answer will be your minor. I have prepared a few examples that might help you to understand better on minor. This is the first example. We are given matrix G and we are asked to find the minor M31 of matrix G. First, you have to identify the row and the column from M31. It's the third row and first column. Then, draw a line across the third row and first column. Now, you are left with four numbers, that is -4, 6, 1 and -1. Do cross multiplication in the matrix. So -4 times -1 minus 6 times 1 will equal to -2, and that will be your minor. This is the second example. So we are given matrix F and we need to find the minor of A33 of matrix F. This question sounds slightly different from the previous one, but the step is still the same. Replace A33 with M33, then you determine the row and column. So it's the third row and the third column. Now, Draw a line across the third row and the third column, and you are left with 4 numbers, that is 2, 0, -5 and 7. Do cross multiplication, so 2 times 7 minus -5 times 0, and your final answer will be 14, and that will be your minor. I hope what I've explained throughout this video helped you to improve your understanding on minor. That's it for this subtopic. Thank you.
A warm welcome and hearty good morning to the gathering. Today, me, Badrumas and Nur Kadira will lead you all through today's class. So here we proceed to another subtopic under 7.2 determinant topic, which is 7.2.3 cofactor. Have you ever used blinders? If so, then you already know the basic of how to create a cofactor. Blinders prevent you from seeing to another side and force you to focus on what's in front of you. A cofactor is the number you get when you remove the column and a row of a designated element in a matrix, which is a just numerical grid in the form of rectangular or a square. Let's know about it. Before we start, students must know the 3 learning outcomes from this lesson. Number 1, learn how to find cofactor. Number 2, calculate determinant. And number 3, understand the cofactor of a matrix through example formulas. Definition. The definition for cofactor is, if A is a square matrix M times N, then the cofactor of Aij is given by cofactor Ij is equal to -1 to the power of I plus j times determinant, or minor Ij. The cofactor is always preceded by a positive or negative sign, depending on the element. -1 to the power of I plus j is functional for determining whether the cofactor is positive or negative. This mathematical concept may sound more complicated than it is. So, let's look at an example. Example 1. Question 1. Find the cofactor 2, 2 from the given matrix. The given matrix A is 3 times 3 matrix. For solution, we already know that A22 indicates the element in the second row in the second column, which is 2. Now, how will you go about finding the cofactor of 2? Well, in order to do that, you would put blinders around the 2 and eliminate the row and column that contain the 2, as shown here. Once you have a new matrix that doesn't include 2, you can calculate the determinant or number derived from a square matrix. You can find the determinant by multiplying the diagonal numbers on the matrix. For example, 3 times 9 is equal to 27, and 6 times 4 is equal to 24. Next, subtract the value of the second diagonal from the value of the first diagonal. 27 minus 24 is equal to 3. Hence, our determinant equals 3. Lastly, check the sign assigned to the element. Let's insert the determinant obtained in our previous formula, which is cofactor Ij is equal to -1 to the power of I plus j times determinant. Write it again as cofactor 2, 2 is equal to -1 to the power of 2 plus 2 times 3. So the result is our cofactor 2, 2 is equal 3. And now I will let Nur Kadira to go through to another example.
Example 2. Find the cofactor P3, 2 given matrix B where the elements are 1, 2, 3, 4, 5, 6, 7, 8, 9. How are we going to solve this? First, find its minor. Since the question is asking for cofactor B3, 2, we have to remove row 3 and column 2. By using the formula of cofactor, -1 I plus j, I is row 3 plus j column 2 multiply with minor 3 2, we will get negative 1 to the power of 5, 1 cross multiply with 6 minus 4 multiply with 3, we will get negative 1 multiply with negative 6, and the final answer will be 6.
So now, me, Alan, and Yenda, we discuss about the core factor expansion. This will make calculating determinant to become a lot easier. Okay, first of all, what is core factor expansion? If A is an n times n matrix, also known as square matrix, and given a matrix A which is A11 all the way down to ANN, the determinant of A can be written as the sum of its core factors multiplied by the entries that generated them. So this is a general introduction on what core factor expansion is. Now, let me explain it in another way. We say the ij core factor expansion of A is capital C with subscripts ij, where Cij is equal to negative 1 to the power of I plus j times the determinant of capital A with subscripts ij. So now we are able to write the determinant A as A11C11 plus A12C12 plus all the way up to A1n C1n. So we no longer have to write the A11 times the determinant of A11 and then subtract and add and subtract and add every single term. Also, please take note that this is the core factor expansion along the first row of A. So basically, there are two types of core factor expansion where we can perform. There are core factor expansion along the ith row and also the jth column. It is advisable to choose the one which you think is easier to solve the questions. And for now, let us proceed with the first example. Given E matrix with these numbers, and we have to calculate the determinant of E by using core factor expansion, obviously. So in these questions, I will explain it along the first column. As we can see here, there are 2 0 there, and I believe this is the easiest way to solve these questions. First of all, the determinant of E is equal to 2 times negative 1 to the power of 1 plus 1. So the reason we choose 2 I already circled in the question there. And as for the power of 1 plus 1, the first one indicates the first row and the second one indicates the first column. So we just cancel off the first row and the first column. We will get the submatrix 3 4 2 4. And next we just repeat the same steps. We take 0 times negative 1 to the power of 2 plus 1. So we cancel off the second row and the first column. We'll get the submatrix 2 3 2 4. And then 0 times negative 1 to the power of 3 plus 1. We cancel off the third row and the first column. We'll get the submatrix 2 3 3 4. Next, we apply the basic calculations and then we'll get 2 times 1 times. Okay, so for the submatrix, we apply the methods which are quite similar with the cross product. So we just take 3 times 4 minus 4 times 2 and then plus 0 plus 0. So we get 2 times 1 times bracket 12 minus add. And last, we get the final answer is add.
Okay, thank you Alan and Yinda. Now I proceed to another two examples. Given that matrix A as shown below and calculate the determinant of A. You guys may use first row or third row to solve the question because both rows have a 0 number. I will use third row to solve the problem. So determinant of A equal to 0 multiplied with negative 1, 3 plus 1, 3 is the third row and 1 is first column. Eliminate, you get 0 4 3 2 plus with 5 multiplied with negative 1, 3 plus 2. Eliminate, you get 3 4 2 2 plus with negative 1 multiplied with negative 1, 3 plus 3. Eliminate, you get 3 0 2 3. And then do the calculation, you get 1 SS answer. Next, calculate the determinant of this matrix. In this matrix, there's no any zero number on it, so you guys may free to use any row or any column to solve the problem. I will use first row to solve. So determinant of this matrix equal to 2 multiply with -1, 1 plus 1, eliminate, you get 1, 2, 4, -1. Plus with -4, multiply with -1, 2 plus 1, eliminate, you get 3, 2, 1, -1. Plus with 3, multiply with -1, 3 plus 1, eliminate, you get 3, 1, 1, 4. Then do the calculation, you'll get -5 as an answer. So in conclusion, in this chapter, you already learned how to find the minor, cofactor, and cofactor expansion to calculate the determinant. So what is the use of determinant? It can be used to determine the existing of inverse of a matrix. If determinant is not equal to 0, an inverse of a matrix can be found. You can learn the inverse of a matrix in next subtopic. Do you have any question? Free to ask us through WhatsApp or type in the comment box. Thank you.